Hello, in this video we will learn how to build a microservice using FastAPI and Docker and serve it as an API by using a Python-based machine learning model. As you can see right here, we will use a pre-trained model scaler and a model for prediction. It is on the artifacts folder right here. Make your copies from the GitHub repo and put your files on your working environment right here and check on terminal you are on correct location. Also, be sure you have installed the Docker desktop application on your local machine. So first of all, clear the terminal screen and go directly to application folder named app. So let's do like this. The first file we need to create in application folder is variables.py. We will use only one package for defining input variables. The package we will use is called Pydantic. It is a data validation and setting management package using Python type annotation. Using Pydantic, we will define input variables in the class named weather variables used for FastAPI service. So, simply import a base model from Pydantic and create a class for variables to be read for our API. So the class name is weather variables and only one argument is base model. We'll use 7 features used in API and we'll list it in this class. All features will be in numerical format and it will be standardized as NumPy float objects. So we are finishing to list our features in variables.py file. Here's all 7 features. It's a wind speed, wind bearing, pressure, current weather conditions. So all 7 features right here. So we need to save it and go move forward. I will move variables.py screen on right here, and so I will define API file. It is called weather_api.py. This file is used to define the FastAPI service. The needed model artifacts are imported and used to serve API endpoints to infer the model for making prediction in real time or in production. Let's put the window to be comfortable to write a Python code right here. We importing the required packages such as Ubicorn. It is an ASGI server implementation package. FastAPI. We also importing the weather variables class previously created in the variables.py file. We will use the variables defined in this file for procuring input data for the FastAPI service. Then continue with NumPy, Pickle, Pandas for data structuring, and ONNX runtime. It is used to deserialize and infer ONNX models. Once we imported all required packages and models, it is a good time to create an application object. For this we are using the function FastAPI. After creating the app object, we will import the necessary model artifacts for inference in the endpoints. Pickle is used to deserialize the data scaler file. It is modal-scaler.pkl. Let's finish write the full path into the file right here. Let's paste the scalar file name right here, and that's it. Also write an argument rb. It is a mode that opens the file in binary format for reading. So now we are ready to directly load the pickle file for scalar into our API file. Next, we need to load the model file itself from the artifacts folder. For this, we will use ONNX runtime to be used to load the serialized model into inference session. So, define the path to the support vector classifier model in the same way as we did before. So, paste the file name of our classifier and it will be done. Next, we need to extract input names and label name for inference session. Beneficial to know that ONNX runtime inference powers machine learning models in key Microsoft products and services across Office, Azure, Bing, as well as dozens of community projects. Basically, ONNX is an open format for machine learning and deep learning models. It allows you to convert deep learning and machine learning models from different frameworks. Next, we can move to the core of the part of defining the API endpoints to infer the machine learning model. To begin, we make a GET request to the index root using the wrapper function at the app and get with a single dash. A function name index is defined for the index route. It returns the welcome message at the index page. Let's finish to write this welcome message, and it is the welcome to the application. Next, we will define the core API endpoint. It is predict, which is used to infer the machine learning model. A wrapper function app.postPredict is used to make a post request. A function named predictWeather is initiated for the endpoint predict. Inside the function, we have created a variable called data that will capture the input data. This variable captures the JSON data we're getting through the post request and points to weather variables. As soon as we do the post request, all the variables in the incoming data will be mapped to variables in the weather variables class from the variable.py file. So now, by using a variables.py file, I am trying to correct map the data and variables in the API file. This procedure will take as many features you have in your project. In this project we have 7 features, so we need to cover all 7 features in this way. Just use both files in the same time to avoid any syntax errors. So only the last feature is left and we'll finish this little part. I hope you get the logic in here. And here is it. And this is all for this piece of code in this project. Next, we convert the data into dictionary, fetch each input variable from the dictionary, and compress them into a NumPy array variable, data to pred. We will use this variable to scale the data and infer the machine learning model. Here we need to feed mapped data to pred variable in the list format as we are doing right here. It is a simple list of variables in NumPy array. Let's finish this list in a second. Fine, it's done right now. The next step in here is to scale this data. The data in data to pred variable is reshaped and scaled using the scaler loaded previously using the fit transform function. This is what I'm doing right now. So data to pred variable is coming here, and I'm just reshaping it to 1/7, and that's it. Next, the modal inference step, which is the key step, is performed by inferencing scaled data to the model. In here, I'm calling a session runtime and giving the label names and input names with a mapping to data to pred variable, then set a data type to numpy float32. And from this list, I'm grabbing the 0 value to getting the correct data. By saying correct data, I mean predictions is delivered by the model in this session. So this step is almost done, and I just grabbed the 0 index from this list. So getting prediction values from the model session is finished, so we can move forward. And now is a good time to get the values of prediction that we will present to the end user. Here the logic is very simple. If a prediction score is above of 0.5, the prediction will be a rain. Otherwise, the prediction will be not rain. This is what we will present for the end user in the API interface. So, the prediction inferred from the model is then returned as the output to the prediction variable. As you can see, we are returning a dictionary type results. This kind of returning result is understandable for most of API services. That's all for the API file right now, and I'm removing the empty line from the bottom. So just save this API file right now, and let's go to the next steps. The next step is to define a list of packages and modules that we will use in our API, and for this we will create a requirement.txt file, and this text file will contain all the packages we needed to run our FastAPI service. So let's start to write this list of the packages that we will use. The first one is NumPy, so it is a FastAPI, and then it will be unicorn. Then it is a scikit-learn, and we will use a version of 0.20.3, and then it is a pandas, then it will be a ONNX, and then ONNX runtime. That's all that we will need. So save it and go next. Just please remember that ONNX runtime is used to deserialize and infer ONNX models to run the FastAPI service. So far we have created 3 different files. The first one is variable.py, then API file, and then requirement.txt. Next, what we have to do is to go to application folder, and then we need to create a Docker file. It is for to creating a Docker image on our local machine. So for this, we go to apps folder right here, and then we need to create a Docker file by touch command in our terminal. This is how we will package the FastAPI service in a standardized way using Docker. So open Dockerfile in our editor and let's start to write some content. Firstly, we use an official FastAPI Docker image from Docker Hub by using a from command and pointing to the image Tangolo, Unicorn, Unicorn, FastAPI, and then we will use a Python version 3.7. Next, we copy the app folder into a directory named app inside a Docker image and container. After this, we will install the necessary packages listed in the file requirement.txt by using the run command. And here is the list of packages that we have listed just before. As the Unicorn server for FastAPI used the port 80 by default, we will expose port 80 for the Docker image we will use. Lastly, we will spin up the server inside the Docker image using the command cmd unicorn web underscore API app dash host 0000 dash port 80. This command points to the weather underscore API.py file to access the FastAPI application object for the service and host it on the port 80 of the image container. So by cmd in this line we telling what the container should do in the terminal. That's all that we have to do with the Docker file. I hope that it was so clear for you, so it's good time to save it and go next. Now we will test the microservice for readiness and see whether and how it works. That is how the current file structure is look like. It's looking good so far, and now let's clear the screen and let's start to build our Docker image. We can do it by typing the following command is docker build -t FastAPI and a dot at the end. So we are seeing that the container is being building. So let's wait a couple of minutes and it will be done. Execution of the build command start building the Docker image following the steps listed in the Docker file. The image is tagged with the name FastAPI. After successful execution of the command, you can validate whether the image is built and tagged successfully or not, using the Docker image command. As you can see in our example, the image is being created successfully. Also, you can check about the success in the Docker desktop application that you should be installed on your local machine. And here is it. Here is a FastAPI image, the same which we have created just a second ago. And now we are ready to run a Docker container locally. Now we can to spawn a running Docker container from a Docker image created previously. To run a Docker container, we will use the run command. A Docker container is spawned from the FastAPI Docker image. The name of the running container is weather container and its port is 80 is mapped to the port 80 of the local computer. Upon successfully running a container ID is output of the terminal, as you can see right here. And on the Docker desktop application, you should also see that your image is running right now. Also, as I told you before, you can check the container image status by Docker image command in your terminal. As you can see, here is the same information that you can see on Docker desktop application right here. So everything is fine, and clear the screen and check if our container is running successfully by Docker container ps command, and here is it. Our container is running fine, and here is a port that is being mapped, and it's mapped to port 80. That means that we can access our API by the port 80. It is the same information on Docker desktop application, so let's go to access our API. Open your browser right now and enter this address. At the index page, here is a welcome message that we have set up the API code. But for now, we need to test our predict API, and then we go to the special page for this. So in this page, we're able to test our get and post request, and in our example, we need to check post predict API request. But before this, you can check that all the data is transferred in the API is correct. Is 7 features that you can see right now. All features are numerical format, as you can see right here, and everything looks fine, so we are ready to go to the post. Here's the example of the payload which is being ingested into the API service. So the response is a string, is looking fine. The request body is JSON, is perfect. Okay, I want to try my custom request to the API. So let's go here, and here is the space where we can to change the values for our payload. So I define some random values for the features. For example, is wind bearing degree is 60, visibility in kilometers is 5.3, pressure is 1013, and condition is 1. Okay, let's press execute, and the response is like this. Okay, the prediction is rain. This is our response body. So basically we made a post call and test our endpoint. So now you can play around your request payloads, and you can change the values of your request like this. So for example, I'm changing the wind speed, and then temperature, humidity, and then you can change the values as you want. Click on execute and see your response, and the response on my side is rain again. So keep special attention that the code is 200. That means its response is good, and then it's additional information that you can navigate. So I hope you had a good time with this tutorial. So congratulations, you have successfully spawned a FastAPI container and tested it. You can monitor your container image directly at Docker desktop application right here. It is very interesting, and I suggest you to invest some time to get more knowledge on monitoring your images. So this exercise should have enriched you with the skills to build, deploy, and test machine learning based API service for your use case. So at the end of this video, I want to special thanks to Emmanuel Ray. He wrote Engineering MLOps book, and I suggest to look at this book and to learn more everything about MLOps. So never stop learning, and see you on the next video.